Hi guys, in this video I'm going to talk about how to create your own C++ string obfuscation error-only library. And before we do this, I'm going to just give you, for example, one reason why you even bother doing so. Let's just say you are having an application and you want make it harder for other people to investigate or see what exactly strings you are using in your binary. So you can use such techniques. And there are also many other reasons for why I'm doing so, but you can read out or Google it out and figure it by yourself. So I'm starting with a plain executable, C++ executable in Visual Studio. We're going to add a new header called let's say obfuscated string.hpp. We're gonna include this library. Make sure everything is compiled. Everything looks good. And now we're gonna create a class that's gonna hold our obfuscated string. So let's call it obfuscated string. Like that. And we want to be able to hold any kind of data. So we're going to make it a template class. So before we are continue, let's just make it template. It's going to get any kind of type. And I have a typo here, template. And I want to be able to figure out the size of the array we are using. So let's say we're using that type. Okay. Yes, okay. Everything compile. So, as I said, we want to hold the obfuscated string here. So what I'm going to do is to make space for it. Give the size of size, and we're going to initialize it because it's a good habit to initialize all your variables like this. Everything is compiled again. And I want to show you guys how you can use this class. Let's just complete it a bit. We're going to make a const expression a constructor, and this is important because we want the compiler will be able to figure out how to initialize this struct in compile time. And we're going to get any kind of an array here. So it's going to be data. Any kind of array can be catched with this signature. Okay. Let's see how it works. So we can build our obfuscated string const expression auto text equal to obfuscated string. Let's say we're using char, and the size is going to be 2 because we want to hold just a single character. So as undeclared identifier. Oh yes, it should be compiled. Okay, this is annoying, and the reason I have to do is because in older versions of CPP, the compiler is not smart enough to deduce the size of this array, and 2 is because technically there is a null terminator at the end of the string. So I mean, if we do something like this, it won't compile, or if we change this number, it won't compile. And we want to make a better version of it. So what we can do is to go out of this class and create a templates function that would create this class for us. So again, it's gonna get size t of size, and let's call it const expression create obfuscated string that receive any kind of array. So const p percent data size. The return value gonna be automatically deduced, and it's specifically gonna be obfuscated string. So with that p and size, we're gonna return the string p and size, and we are gonna pass in the data as is. Everything should be compiled. And actually what I did is to move that deduction of types to this place, to these functions, because the types can be deduced from function and not directly from class initializations in our main function. So instead of writing this, I can now do something like const expression auto text to create obfuscated string with no types specifically. I'm gonna call it text. It compiled. Cool. So I can get rid of this. And move on to the actual obfuscation. So what we're gonna use is something called indexed sequence. And indexed sequence is implemented in a library called utility. So we will create another constructor. It must be const expression obfuscated string that's gonna get. First of all, it's gonna have it's gonna be a template class with the type with a variadic template like this. Indices, and this is going to represent the indices of the obfuscated text we're going to have. So this function also going to accept any type of array. And it's going to get std indexed sequence with indices. And this constructor are a public interface to the use case application, to our main application. Is going to call this private const expression constructor. So obfuscated string, passing the data as is, and we're going to use a function called std make indexed sequence with the size -1, because we don't care about the null terminator. We don't want to mess up with it. Okay, so we would be able to get eventually a legit string. We call it that way. And let's see if it compiles. It should. Everything going well so far. And I remind you, this is our use case. Now, actually, because everything is a const expression, you can eventually see that I'm getting all those zeros. You see, all those zeros, because the compiler know even before compilation, in the pre-compiled phase of our application, the compiler know what that member holds. And this is actually what we are using to get a all compiled and obfuscated string. So let's talk about the obfuscation itself. This constructor should take the initialization of this m data variable with the obfuscated string eventually. So we're gonna initialize this member by following. We need, of course, before we initialize this, let's, you know what, yes, before we actually initialize it, we should be able to have a constant expression obfuscate function that return us, of course, the same element as we passed here. It's gonna get a const t reference to some element. You know what? I like to write it like this. And let's say we're gonna increase each character by 1. So we're returning an element by 1. And we want to use that function. So what we're gonna do, as before, we are gonna initialize our m data variable like this. We're gonna use template packing, so make sure you understand what template packing is and what variadic templates are. So m underscore data is initialized that way. We're gonna call the obfuscate function with some element, and element is gonna be data with position of indices, and this is gonna be expanded, unpacked to every index we're using. And it compiled. What it's basically done so far, it's obfuscated at compile time this message. So how I know it works, you see that there is 117, 102, 121, 117. This is obfuscated string embedded in our binary, even before compilation. So I'm going to prove it to you like so. If we are putting here an A, we can see we're getting a 98. And a 98 is actually not an A, it's a B. And if we will use Python, I can demonstrate it to you. So Python char of A, sorry, char of 97, char of 97, sorry, is A, and char of 98 is B. And what we are getting here is 98. So B is inserted instead of A. And this is cool. This is what we want. So this is basically it. But we're gonna add some cool features to it. So let's say you are having you have a function. Let's say that called foo void foo that is accepting a string. So const std string reference. I don't have string, so I need to include string, this string reference with some text. And you are basically just print it out. So include IO stream, see out of the text. This is your function, and you want to use that obfuscated string in your function. So you can't just foo that text right now because it don't know how to convert that class into this. So what we're gonna do, you see, it won't compile. What we're gonna do is to add a public interface for casting. So it's gonna be operator std string. Operator std string. That's what it's gonna do is to return. Um, just a sec. I need to charge my PC. Yeah, so sorry for that, guys. I had to charge the laptop. Let's see. So we talked about yes, we cannot cast this as is, so we need to add string operator casting to std string, and we can do the following, guys. We can implement the obfuscation algorithm for that obfuscation, and the ideal would be if you would be able to use the same obfuscate, but element plus one is not an inverse function of itself. So we need to implement the inverse function again. So we can do something like this. We can, because we are not we are increasing by one each element, we can just do the opposite. So we're gonna loop for size ti equal to 0, I is less than the size minus 1, and now just the size. Yes. And we basically can initialize an array called result with that size first. That way. Okay, and eventually we're gonna return this std string from that array. So for each element in result uses result at the I indexed should be data at index minus 1. So yes, this is first of all we are initialize it to 0, and then we are subtracting 1 from each element, and we are making a string out of it. Should file the string is not a member of std. This is because I need to add string here also. And voila, this works. So what we can see now that, let's say we are this text here, and we're gonna run it like Control F5. We are getting a test. This is the deobfuscated string. And it looks like we somehow messed up with the null terminator. So let's see it again. We're passing size minus 1. We are check. Yes, so we just iterated too much. So, okay. Now what I'm gonna show you is that how it looks behind the scene. I can assure you that this text is now available in the embedded in the binary. So I can prove it to you by going to sysinternals tools. I'm using cd sysinternals strings on that binary. On that binary. I'm sorry. This is all the strings in that binary, and I'm gonna search for the word test, and there isn't. And this is a proof that this uh, argument, this string, is not part of the binary. But what is in the binary? Well, we can check using IDA. What's going on there? So let's open it with IDA. We can use strings demo 664 debug string demo, and we are gonna load the symbols, and we are gonna look for our main function here to the entry point. This is it, I think. And you see test is actually now U, T, U, F, T, and U, which is exactly element plus one for each character in test. You see this is T, E, S, and T. The compiler decided to create that string using these instructions, and if someone would eventually look exactly for test, you won't find it. But you see, it's still easy to figure out eventually if someone is determined enough to do so, to figure out what was the original string we are using. But it's definitely gonna make his life much more harder. So that's it. I hope you enjoyed, and goodbye.